Jai Shri Gurudev. Good morning, students. In our previous class, we studied about few examples related to the pressure. That is, decrease in area increases the pressure. We studied about few examples, that is knife, axe, a pair of pliers, pin, nail, etc. So these were the things we studied for that. And others we studied about increase in area decreases the pressure. Here we studied about the examples of heels and skiers, army tanks, and a truck wheel contains a 6 to 8 wheels, and a camel foot has got a large surface area so that the pressure increases, and the horse has got a less area so the pressure exerted by the horse feet is very less. So apart from that, we studied about the examples of school bags, and we also studied about the wooden sleepers placed on the railway tracks, and we studied about the differences between the thrust and the pressure. So students, in today's class we are going to study about the liquid pressure and its factors. So first let us study what is liquid pressure. You all know a solid also exert a pressure on a surface due to its own weight. We will call that as a thrust. That means let us take an example of a body which has a mass 50 kg weight. Now how much pressure it is exerting? It is exerting a thrust of 50 kg F. So similarly, like a solids, liquids also have weight. They also exert pressure on the container in which they are kept. You have to remember one thing, students, here. In a solid, a force is acting normally, we will call that as a thrust, but here in a liquid it is exerting a pressure on container in which they are kept. That means if a liquid is kept in a cylinder, the pressure is exerted on that cylinder. If the liquid is kept in a glass, the pressure is exerted on a glass. Here glass or a cylinder is a container. A solid exerts pressure only on the surface at its bottom. So a solid exerts pressure only on its bottom. So but a liquid exerts pressure not only on the surface of its container at the bottom but also sideways, that is in all direction. You have to remember one thing, students, here. Solid exerts pressure on the surface at its bottom, but whereas a liquid exerts a pressure not only at a bottom but also sideways in all directions. So to understand this, let us go through with a few activities. So here we have activity 3 in this chapter, that is to show liquid exerts pressure at the bottom of its container. This is the experimental setup. So here we have taken a 2 glass tubes, and deflated balloon means the balloon which is not blown there. Here we can see in the figure B bulged balloon, and here in the figure B inside this glass tube a water is filled. Okay, students. Now we are going to conduct this activity when you are back to the school. To understand this, let us go through with this activity. Now take a glass tube. Now I am going to take a glass tube. So tie a balloon at its lower end. You can see here deflated balloon. Here the balloon is tied at the lower end. Okay. So hold it vertically straight as shown in the figure 3.21a. So this is a figure A. So this is figure A. So hold this vertically as shown in the figure. So this is about the first thing. So in the second case, pour some water into the same tube. So now you are going to pour some water into the same tube. Now what is happening here? So you will notice that the balloon bulges out. That means when you are pouring the water from the top of this glass tube, here you can see, when you are pouring water from here, the balloon will start bulging. That means the balloon bulges out. So what did you understand from this experiment is water column exerts a pressure on the balloon. So the force on the balloon is equal to the weight of the water column, which is called thrust. So here the force on the balloon is formed by this water. So it is equal to the weight of the water inside that glass tube. We will call that as a thrust. So if W is the weight of the water column and A is the area of mouth of the balloon, then we have the formula for thrust, that is thrust is equals to W. So here students, you have to know one thing. So if W is the weight of the water column, A is the area of mouth of the balloon, then we will denote thrust by W. What do you mean by thrust in this experiment? Thrust is nothing but the weight of the water column. So thrust is equals to W. So you already know about the formula for pressure. What is the formula for pressure? Pressure is equals to thrust by area. This equals to W by A. Why I have written W? In this experiment, W is called the thrust. That means a weight of the water column. So this is about the one activity. So let us go for the next activity. That means liquid exerts pressure on the sideways also on the walls of container. So in the first one we studied about the liquid exerts pressure at the bottom of the container, but in this activity we are going to study about liquid exerts pressure sideways also on the walls of the container. So this is about the second experimental setup. So it is similar to first one, but here we have a hole made on the side of this glass tube. Okay, so take a glass tube closed at one end and having an opening in its side near the bottom. So you can see the glass tube here. So here one end is already closed and the sideways has been opened here. Okay, now tie a balloon at the side opening of the tube. So here you can see the balloon is tied at the side opening. Okay, so now hold the tube vertically as shown in the figure 3.22a. So now imagine I am holding this tube vertically as shown in the figure. Now pour some water in the tube. You will notice that the balloon bulges out. What will happen when you pour the water inside the glass tube? The balloon will start bulging. So what you understand from this experiment is, so liquid exerts pressure not only at bottom but also on the sideways, also on the walls of the container. Students, you have to observe one thing. So here the balloon is bulged because the liquid is exerting a pressure in the sideways also. So these are the two activities. So first one, liquid exerts pressure at the bottom of the container. Second one, liquid exerts pressure on the sideways of walls of the container.